continuation of Ndefo Okigbo classes. We are still working on beams. This case, beams that are continuous beams that would have been otherwise indeterminate. But because of the introduction of hinges, if you watch this beam A, D, B, E, C, you will see that there is a hinge is introduced at D and another hinge is introduced at E. In the first one I did, in the first continuous beam that was done, it was only one hinge. The reason it was that that continuous beam was 1 degree indeterminate. By introducing that hinge, that indeterminacy, that was 1 degree was removed. That was why we could solve it as simply supported beam. Now, this one is about 2 degrees indeterminate because the reaction, the support at C has 3 unknowns, 3 reactions. The support at B has 1. At A has 2. So it became 2 degrees indeterminate because B and C gave you 3 reactions which could be taken care of by the equation of static. So 2 remain at A, which is 2 degrees indeterminate. And for me to make this beam that is 2 degrees indeterminate determinate, I introduced 2 hinges because I want to solve it as simply supported beam, as a determinate beam. So I made it determinate by introducing 2 hinges. And not that I just made it, but a beam that is continuous with hinges. Hinges could make it determinate. The appearance of hinges in the beam could make it determinate because the hinges removes the resisting bending moment, resisting stiffness. That's why the point of the beam becomes a flexible point. Beam is the point of flexibility. The hinge is a point of flexibility. The point of the hinge becomes a flexible point, and as such, there is no more moment resistance at those points. That made this beam now determinate. So since the beam is determinate now, I can conveniently decide to break the beam at the points of hinges so that I can solve them. I can solve the different parts, part by part, the way I did in the first one. If you watch here, if I break it, look at the breakage here. The breakage is that the beam, the position from A to D was broken at the hinge D. And look at it, it has been broken. And because itself alone cannot stand on its own because it will be unstable. This leg alone cannot carry it. So we rested it on a more stable position, which is position DBE. It's more stable than AD. So we rested it on DBE. And when we rested it at DBE, because we cut the next hinge at point, we cut it because that's where the next hinge hit at point E. So we cut it at that point to get another part of the beam, which is DBE. And we had to rest it on the most stable part of the beam, which is EEC, is the most stable, because point E has 3 reactions that could sustain a beam, whether it is pushed horizontally or pushed vertically, or even if it's rotated. All those resisting reactions are in C. So that's the most stable part of the beam. So that's why it has to be the last one to carry the whole of them, because the part AD was carried by DBC, and the part DBC is carried by EC. So that's how the beams are broken. And in this way now, I can now take them part by part and solve them. The first one I want to solve is AD. I take AD, the way I did before. To solve AD, I start by getting the reactions. I want to get reaction A. I say total moment about D is equal to 0. I have the length of reaction A from D is 4. So I have 4 RA, then minus the load. 3 times 4 is the total load times half of it, half of the distance, because that's from the center of gravity to point D. So times 3 minus 3 times 4, 3 times 4 times half of what times 2 equal to 0. So I have this person.